All right, thanks everybody for joining in. It's 10:59. I'll give it 1 or 2 more minutes, let everybody trickle in, and then we'll start with our presentation. All right, so it hit 11 o'clock. Thanks everybody again for joining into our monthly webinar. Today we have a guest host, George Gregory, who is a subject matter expert with tanks. He's been in this field for quite a long time, and he is a third-party engineer, PE, that we use to approve some of our repairs and analyze some of our repair plans. So today we're going to go through some of the repairs we've worked with George, and also some of his repairs that he's done outside of our territory here in Houston. We're going to go through and see how our Belzona repairs are meeting the code and providing long-term repairs. So George is a tank expert, so we're sticking mainly to tank repairs, and since we are the experts in non-metallics, we're doing tank repairs with non-metallics. So where it started, I like to always give a little introduction to where it started and what we're using. So as you can see here in this picture, we have a carbon fiber.
In general, the introduction will introduce.
Sorry. We have a carbon fiber reinforced engineered wrap. This was started 30 plus years ago, and the main application for this system was high pressure pipelines, so repair on pipelines. So it was made with some of the strongest materials, fiberglass, carbon fiber, epoxy resins, and it was made to withstand high pressures, 1,000 psi, 2,000 psi, ensure that the pipelines are running safely, there's no accidents, everything's safe. So this was a composite standard. ASME PCC2 Article 401 was made for high risk applications. Over the years, because of the success it had in the pipeline and the heavy piping and high pressure situations, it's gone for more than that. So now it's being approved for tanks and pressure vessels, which are actually a little bit easier applications when it comes to this composite engineered system. So just to give you an idea of some of the repairs that it's always been used for, this is a 20-inch riser pipe in the Gulf of Mexico. As you can see, it's over the water. This is not only a high risk application, but an environmental application. You definitely don't want anything spilling overboard. Very critical line, a lot of everything depending for the platform on this line. So it was operating at 700 psi with a 1/2 inch hole. We designed a system to wrap this, and it was able to contain this pressure. It was accepted by the DOT, and it operated for 5+ years until they had an opportunity to do what they had to do. So now, you can use it for the high pressure scenarios. So now over the time, the industry has led to use it for other applications such as tank floors, any type of tank repair. So I'm going to start here with the tank floor that was leaking from several defect locations. 210-degree heavy paraffinic solution in there. There were several holes, so we ended up using an epoxy coating in conjunction with a fiberglass mesh to contain these leaks and stop it from leaking anymore. So George, you have a lot of experience, and you probably have 20+ ways that you could fix this. So why would you use our system here, and what made you think this was a fit for service solution for this tank?
Well, thanks, Alex, for inviting me. As we look forward into API 653, and we're moving forward into online repairs, online inspections, what have you. So the interesting thing about it is isolated pittings, and we talk about API 652. The reason being is it allows us now to get in and make that turnaround a lot quicker, prevent a lot less hazard by not having to weld. Since the API code now allows us to use cold bonded type repair, it just fits into the scenario of removing risk for long-term operation of the asset, but as allows us to be more practical, because a lot of folks, we go to goal zero. We don't want to create an environment we don't have to. So again, most bottoms, when you go into them, unless they're completely corroded away, what you're going to find is you're going to find mostly isolated pits because of the inspection technique. Then the prove ups, typically when you do a tank inspection, based upon my own practical experience of being in tanks, inspecting them, and then working with the major oil companies, is you're going to find a lot of isolated pitting. And isolated pits, I believe, in my opinion, using a non-bonded type of repair allows me to be more flexible. And again, my turnaround times become a lot less. So, and yeah, that's my experience so far. And in doing this type of repair, what it's allowed us to do is sometimes we get with customers who are way behind. And again, my first company I worked for was Shell. So get way behind on your tank program, on your integrity program, on taking your tanks out of service. So I'm constantly looking for the best possible process to get through those inspections and actually get back in service, right? So even though we're out of, we have a lot of tanks that we have deferred. Unfortunately, what happens in the industry now is the assets are getting sold that we're not trying to catch up. So in this particular application, isolated pitting, obviously not through the threshold as API allows me to get obviously to 0.05. But what it allows me to do is get in and out relatively fast. So don't have to mobilize a specialized tank team, which cost me quite a bit of money anyhow. And that specialized services with welders is going away anyhow. So this made sense. You're looking at a tank here. Turnaround tanks now for this particular application has been basically a 1 week from the time we blind it, clean it, inspect it, and repair it. So it gives me greater flexibility. So hopefully that helped out. This is just an example of one of the tanks we worked on.
Yeah, that's good stuff. And then also just to add, we do have a lot of, so what you're looking at here is our engineered wrap, Super Wrap 2, which is a epoxy resin combined into a carbon fiber fiberglass hybrid reinforcement. And it's another thing you want to add there is it's corrosion resistant. It's tested against a variety of chemicals. So we're going to be compatible with whatever chemical is in there. And then if we need additional protection, we have 20 different coatings that we could apply over the top to make it even more chemical resistant. If you have, let's say, a 98% sulfuric acid tank or another a solvent or something that's more aggressive, we can always top coat it. So chemical compatibility is another thing we look into to make sure everything's compatible with the fluid. So going from the floor to the shell, molten sulfur tank, localized corrosion due to a steam jacket leak led to 2 large holes. We designed a Super Wrap 2 ASME engineered wrap for the defect. And I guess my question here is, George, why do you think API 653 has now included non-metallics that are designed to ASME PCC2 as an approved repair? Because it's definitely something that came up in the last couple of years. So what made you think they pull that switch to this system as an approved repair?
I think what's happening in the industry is obviously have quite a bit of aging assets out there. And the new focus is really on anything that's online inspections, online repairs. That's why you're seeing a lot of interest in robotics. But because again, I think people are just starting to come back around to, like you said before, you have 30 plus years of application, right, for pressurized pipelines. This is just a good model to move into something that's low pressure, right? And typically this can do a lot of help a lot in mostly isolated pittings, things on shells, especially under any kind of insulation. That's been a problem. But I don't want to take the tank out of service, and I definitely don't want to do hot work if I don't have to. And it's got enough strength that allows me to be approved design. So again, it just kind of fits into how much of the maintenance can we do online versus taking anything out of service that's going to take that asset out and reduce my margin at whatever facility. In today's world, we want to be as competitive as possible.
Exactly. And this repair was done online. Tank level was lowered just under the hole, and we went in with a vapor blaster, which is an abrasive blaster that has a constant flow of water. So it's not a hot work, no sparks whatsoever. And we were able to install this in 1 day, and it's fully cured in 24 hours, and they're able to raise up the level of the tank after that. So cost effective and also low risk when it comes to a tank due to, like you said, the pressure retention of this system is quite high, built for high pressure piping. Taking it to the roof, Definitely a common issue we see across the board, especially with floating roofs, but we also do a lot of fixed roofs as well. API 653, any method of repair that is acceptable that will restore the roof to a condition enabling it to perform. We take that as what we need to do is install a system that's going to stop it from leaking and keep it from leaking. So it's got to do both. A lot of the times we're repairing this, and the reason that they're going to go with our system is because, like George says, we can do it online. We can stop the leak live depending on the leak and the chemical. And then once you stop it, you're going to want to put another composite on top of that. I have a little diagram of what we do to make it have more longevity. So additional requirements for the most part, you're going to be dealing with hazardous fluids. You definitely can't have sparks or hot work. And so we use our vapor blasting and sparkless power tools for most of these applications. Someone drew something here. So the first part of a tank repair is normally to stop the leak. That's the reason we're up there. We've with a lot of our clients now, when we're on a tank that has leaks, we're also hitting areas that they think are going to leak in the future. So we're hitting areas with a lot of corrosion, especially welds. So this part of the repair, stopping the leak live, is not part of it, which is always going to make it a little bit easier. So the leak is usually the toughest part. But we got a lot of tools in our tool belt. We have surface tolerant rapid cure materials such as 1212, 9611. We're able to stop a lot of leaks that you wouldn't think that you could. Once we stop it, we usually like to do a better prep job. So we'll normally do a small prep around the hole while it's leaking. Once we have it stopped and it's a little bit cleaner and there's no chemicals around, we'll do a better prep and make a larger repair. At times, we'll put our fatigue resistant adhesives, especially for floating rooftop tanks with all the movement. And then we'll normally put a composite patch to give it a little bit more rigidity and a little bit more pressure retention. I think Barry, you're drawing on the sheet here. And then on top of that, when you're dealing with a roof, you're going to have a lot of sun. And if you're dealing with the floating roof, you're going to have a lot of movement. So at times we'll add our flexible systems on top. And then we always like to put our UV resistant systems to give them that longevity. So this is what it looks like in the end. It's tough conditions. Definitely, you're in a hazardous environment. Most of the time we're using breathing air. You're dealing with a tank that's dirty. The roof has had leaks for years and it's saturated with oil or chemicals. So you really have to have products that can handle that contamination. You have to have a team that knows what they're doing. But in the end, if you do it right, you can take a tank that was not environmentally, you have environmental issues and now you don't. So George, I mean, you definitely have worked with us for a while. Is this something that, is relatively new, or were they always doing this, or how do you think this has developed over the years, and what do you think about this solution?
I think what's happening is, if anybody's worked on tanks, I've been in the business now, I think for 34 years, is that interesting enough, when you're in the tank repair maintenance kind of area, when you sell Belzone on a tank, you're kind of not necessarily pissed off, but you knew you couldn't get this stuff off. So most of the time we used to see, when we go out and bid these jobs, it was like, oh, it's Belzone, you cut it out, replace it. So I think the technology now is moving toward a more usable design to allow me more flexibility in my repairs to storage tanks. So again, if anybody's ever worked on Belzone, you try to take that stuff off, when you're in the field, you're just like, this stuff doesn't come off. So we ended up usually cut that steel out and replace with new steel. So as we progress, we're trying to look at, maybe this is a good, alternative to welding on storage tanks. So in this particular case for floating roofs, ideally, you're just trying to prevent it from leaking. That can be a piece of plastic if you had to, because again, this is just vapor, hold the product contain, vapors inside. But that's the interesting thing. The journey has gone from something that we always used to use this to fix our tanks anyhow. Now it's more into a more specialized design, and the industry is coming around to accepting it as more of a fixed time-based design versus temporary. So I think that's kind of where we're headed.
Yeah, going into this is where we really did a time-based repair. So this was a project we worked with George. pretty hot one, upset, caused an unplanned shutdown for a process vessel. So now we're moving towards a vessel, but we're using all of our tools that we use in tanks and pipes, and we're taking them into a vessel. So they had an upset, did an inspection, found some stress corrosion cracking, and really it was going to be a limited shutdown. You know how it is. Downtime is going to cost a lot of money per day. So how can we get this back in service safely and effectively? So we came into a two-stage approach. The first stage, which was the fastest way to get this back up and running, and also whenever you can repair something from the inside, that's always going to help a lot because you're going to stop the corrosion source. So that's what we wanted to do here. We wanted to put a barrier between the steel and the fluid. So we went with a fiberglass reinforced liner, installed that fairly quickly, 2-3 days. It was done and cured. And then the next stage, which was going to be during the next planned turnaround, a little bit longer of a repair, was going to be to wrap the whole external of the vessel with an ASME engineered wrap, which is now an API 510 approved repair for pressure vessels. So that's going to give them their API 510 approval. We've stopped the corrosion source from the inside. They did a minor inspection 2 months after the installment of the interior repair. Everything looked perfect. All the leaks are stopped. No further degradation of the liner. This is a picture of the liner on the inside. So what we did was we combined our fiberglass to give it pressure retention, and combined it with a high temperature coating that's compatible to the fluid. So during the next turnaround, we're going to install the external API 510 approved ASME engineered wrap, and that's going to add the structural reinforcement and also give them that API stamp there. So how, George, we worked with you on this one. You're the tank expert. What did you do to combine all your tank knowledge with our super wrap knowledge, and how are you able to say this is a repair that's fit for service? And just to give you guys this was a low pressure vessel.
Yeah, so thanks, Alex. I just went back to the article that you provided for the pipelines and looked at pressure, looked at the vessel as anybody would as a piece of pipe, and then utilized the acceptable ASME practices, and again just looked at the wall thicknesses and the pressure, and then worked your way back into the design you guys provided. So in this particular case, again, in every pipe wrap, what I'm looking at is is it acceptable by the code, which it is, and then go back into the design criteria and look at the design from that standpoint. So so that's basically, again, just following the code and see what's allowable.
Definitely. And I think this is going to be the fun part here. This is I think what you originally, I think we first you came to us about a year ago, and one of your big interests was tank modifications. So I think you were installing some brackets for some new insulation that was going to be installed, and instead of shutting down the tank, emptying it, cleaning it, and welding on the brackets, you were asking us for information on what would be our best bonding material. You're already looking into using non-metallics for bonding, and that's what it's been pushed a lot, and we've been using it quite a bit. So instead of welding on brackets or welding on, as you can see on the right there, they're putting a sprinkler system on. Why shut down the tank? We can come in there with the tank in service and do modifications to the tank. It can be anything from installing vents, brackets, nozzles. There's different things you can do while the tank's in service to not use that money in your turnaround budget, save for the turnaround budget, or to make your turnaround faster, as you can see in our next application that I wanted to show. This is an application where we bonded a nozzle while the tank was in service, and once they were going to go into their turnaround, they were able to cold cut an injection port into the nozzle, and they used this to put in high pressure water to clean out the bottoms of their tanks where all the solids were settling. So they were able to do some of their turnaround work before the turnaround started, so it made the turnaround quick. And I know, George, you had a pretty good interest in using this for a lot of applications, and what's your thoughts on using this instead of traditional welding?
Well, again, it just depends on the level risk that the site has. A lot of times, hot work is obviously from a higher risk standpoint. So most of the time on tanks, the major cost of any tank cleaning is going to be your waste disposal. So anytime you can do an online cleaning, online mixing whatsoever, your costs are going to be dramatically reduced if you go to clean a tank. So the way I used to tell people when I'm working on storage tanks is, it's about what do you pump in and what you pump out, right? So the key to any type of cleaning is pumpable fluid, right? If you can't pump it, someone's got to go and shovel it out. So
Yeah.
I like this application. It's competing with your standard hot tap nozzle, and again, a lot safer. As long as you can get the product pumped in there, um, it's going to reduce your cleaning costs and your turnaround costs considerably. And so, again, back to the theme of the industry now is what can anybody do online, not take that asset out of service and keep making money on it. So I like this opportunity.
I think one of our biggest hurdles is the strength of the bond. And we have simple calculations that we can make. We know exactly how much adhesion our materials are going to get. We've lifted up cars based on our adhesion numbers, so we can use our adhesion numbers to calculate what kind of load it's going to take, especially if you're putting on brackets or putting on something that's going to be load bearing. I think that's been a challenge. So what makes you comfortable using Belzona? I know you say you like our reports and the data we have. What makes you comfortable putting this on and having a weight bearing on it?
Well, I think you still have to go back to, every code, every standard that you have. It tells you have to deal, you're supposed to have access to engineers, tank engineers and specialists that know how to design, repair and those kind of things. So just practicality is looking at the design strength of the bond, which everyone knows is going to be generated by that surface profile that you generate, comparing it to a periphery weld or a fillet weld. So again, it's not a hard calculation. It's just getting to looking at a Belzona product that's gone through the testing requirements to ASTM and verifying that the strength coefficients and stuff are there, and then try to apply that application to obviously a piece of steel versus a fillet weld. So again, a lot of times in the industry, when you look at a fillet weld, especially if you look at your design calculations, unfortunately, I do a lot with tanks, but there's not a lot of calculations that go into handrails. But if you dig into it, it's going to be that fillet weld. So as long as I get the strength and multiply by a factor of safety for that fillet weld, I know I'm in good shape. So just again, we're just comparing a cold bonded type of bond versus the standard joint design or fillet weld that's available on the tanks today.
Definitely, that's something we've been battling. We've been doing bonding repairs for 20 plus years, and using the same calculations we've had, but we've had a lot of challenges or not accepting it. And so what we've done over the years is just increased our testing and also increased our product portfolio. So one of the most recent ones we've one of the biggest things we always said was, what about fatigue testing? That was one of the questions we got on a lot of bonded repairs. So we've created a product, Belzona 7311, that has fatigue testing to 10 million cycles. So if we're doing a high profile job, which to me a handrail is a high profile job, you're going to have people that can potentially be using this handrail. I'm going to use my best bonding material. I'm going to include that safety factor like you mentioned, and I'm going to use the best surface preparation possible. So for this application here, we blasted. We had our trained guys go in. That's another thing we haven't talked too much about, George, is the how much easier it is to install this or train somebody to install this versus installing a good weld. I mean, you would say it's pretty simple when it comes to the application in QA/QC for a bonded repair compared to a weld.
We're working with you, Alex. I said, and going through the QA/QC process, the design, what have you. A lot of times, I believe we're doing more above and beyond typical standard repairs that you just turn over to a repair contractor. So, depending upon a level of design detail that you get into, this is again well thought after and very well designed, in my opinion, to give me a level of security or level of reduced risk to putting it on. And again, when we look at these applications, remember kind of where we're going, right? Ideally, if you own storage tanks, you don't really ever want anybody on top of your tank. So
Yeah.
some places I work, we're actually you're cutting, uh, spiral staircases off. If you got a floating roof tank, people want to get rid of the rolling ladder. So fundamentally, I want to get to applications where they're practical, but yet knowing where the industry is going, at some point, no one's ever going to get on that roof. So, and the other, customers have gone through and say, you know what, we just condemn but this is a great alternative. Again, don't create risk where you don't have to, and just make sure everybody's comfortable. So that's my thought on some of the structural things. Again, more engineering goes into it, more design, more application, as far as QA, QC on the surface prep. Testing is a little higher. But again, I like that as an engineer because most of the time we're not getting that, even with our basic repairs that we have on storage tanks today and I hate to say this, as the industry progresses in age, right, we're losing a lot of the talent that we used to have. I get into this discussion sometimes with people, 20, 30 years ago, some of the stuff was not an issue. But you got to remember, a lot of these guys who know what they're doing are retiring and leaving the industry. So we got to kind of bring that back somehow through better technology or better use of or transmitting information to each other. So anyhow, I think this is just another opportunity.
It's a great point, great point. And just to give a background on this application, they had some welded handrails that obviously your weld is your corrosion spot, and had a scare with one of them that the weld wasn't holding too well. So we came in and blasted 7 different spots and put the brackets down, and then the new handrails were bolted to that. So as you can see here, we're using magnets to compress the cold plate bond. So the way you apply these is you prep your surface, you wet out the underside of the plate and the repair area, and you want to compress down the plate so the adhesive is, pushes out all the air and excess material. And pretty simple application, and gives you that longevity and safety throughout the application that you need. So that's about it. I wanted to keep it as a short presentation so we have some time for questions. I think I see some chats here. Quinn, you want to help us out on if there's any questions, any comments on the presentation?
No, we don't have any questions right now. We did have Dalston show some examples of furniture, railings, different types of stuff that can be stairs attached to a tank while in service without having to utilize any hot work.
That's great. Yeah, it's definitely been a topic. I've been Belzona for about 5 years, a little more than 5 years, and it was hot when I started, and I think it's only getting to be more of a common application out in the field, as the tanks and with your budget and just trying to keep those tanks running as long as possible, like George says, in and out. That's what you need the tank to do and stay in service. So any other questions, any applications that you'd like to review?
Yeah, if you need to, just unmute yourselves and just ask on the Zoom, and we can talk about it right here, right now.
Again, thanks everybody for taking time today. Thanks George for joining in. George is one of our third-party PEs. He can help with any application you guys have with us, or work directly with him. We work with him quite a bit. You cover what, the whole US, George? You go across other countries too?
Yeah, interesting enough that in my title, Virtual Tank Solutions, because obviously through the COVID, what have you, we can work anywhere as long as you have access to the tank itself. There's a lot we can do virtually to assist you, either at scope development, inspections, what have you, and repairs.
Perfect. Thanks for joining, George. We appreciate your help. Look forward to doing some more projects with you, and look forward to working with anyone else here. If you want some more information, feel free to email us. Our consultants will probably be reaching out to you, asking you questions if you had any, and we look forward to the next application.
Thanks, guys.
So I did see one question here at the end. You mentioned weld location is a corrosion point. Does bonding eliminate that corrosion risk? Yeah, that's one of the main things you're going to get with a cold bond versus a weld is you're not creating a heat affected zone. Another problem with welding on a tank or vessel is if you have an internal liner, you can damage that. If you have really low metal thickness, your weld can, create a hole as well. So we can bond onto metal that's not weldable, and you're not going to have that corrosion issue at the weld. A lot of times